Hello all. So today we are going to check whether different two type of solar lights can be charged with artificial light source, especially within indoor. So I'm going to use a mobile flashlight coming from a very small old type mobile phone, and I do have some external LED light source as well. Right? This light source has three different color temperatures, so we can test all those things whether they are having any kind of a power generation difference. And I have another external flashlight type light source as well. So we will use these three different external light source on these two different solar lights and see whether they can be charged. This is actually a motion activated type solar light, and this is a garden solar light. Here's the solar panel, and this is a pretty cheap one. Mostly these are available in Amazon within a few dollar range, right? They are not so much expensive. And for the measurement part, I'm using this unity multimeter. This is a really good multimeter. We are going to deassemble these two solar lights and take the circuitry, remove the battery. After that, we will mount these props into the direct line of solar panel and see whether we can check any kind of a power generation happening with this artificial solar light. If the power generation is okay with the artificial solar light, then we can assume that those generated electrons, the electricity is enough to charge our solar batteries. And for a comparison, I'm going to take these solar light circuitries into a direct sunlight as well and see how much power these small solar panels can produce under direct sunlight, so we can have a certain comparison with these basic artificial solar lights and under direct sunlight how it will looks like. Okay, so first of all, let's deassemble this solar light. So I can remove this part. You can see this is kind of a empty space. The light is here, LED, and we do have on off switch. All right, so we have wires coming from the solar panel. They are kind of glued, so we may not have certain good locations to mount our electrodes from the multimeter. Anyway, this is the charging circuit, and we have soldering point, so we will try to use those things. And here's the battery, 1.2 voltage the capacity, and the current ratings will be 600 milliampere per hour, right? And let's remove the battery from here. Okay, right now let me check the wires. Where do they go? Okay, this black wire, it's coming into this point, and the white line, yeah, it's here. So that means this is one of the electrode coming from the solar panel, and this is the other one. So we can use these two to check the current generation of this solar panel. Okay, let's test this one. For this part I have to change the multimeters values props into here. Now this is where we are put to measure the milliampere or microampere range current, and I'm going to move the knob to milliampere range, and let's see, these are the ones. Okay, I think you can see the display of my multimeter. It's 0, right? Almost 0. That means no power generation. All right. So once I change the portion of my solar panel, you can see now it's actually facing toward our room light, indoor light, and there is a small percentage of milliampere. Right, this current actually generated by the environmental light, and since my setup is near my window, there are certain amount of small solar light coming to this panel as well. And when I move my fingers, I think I am slowly losing the contact. Anyway, let's try to test everything. So first of all, I'm going to use this one. Okay, let's see. All right, so we can see a big difference, right? It's almost, when the light is directed, it seems to be ranging around 0.5 to 0.6 milliampere. Okay, so and I turn off. Yeah, the current actually not in the room environment, it's not milliampere, it's actually in a microampere range. So in milliampere range, it's not, it's around actually 0.01, right? Okay, now let's test with this one. Okay, it does have the same kind of a light effect, right? You can see the solar panel is responding to any kind of artificial solar. Now all these artificial flashlight and these lights, they tend to have cooler light tone, right? But with my this solar, sorry, not solar, this light source, right? With that one, we can change the temperature of external light. Let's see. I have just mounted that one on top of this setup, and we do have controlling setup here. Okay, props are, now I'm going to turn off. Right, now this is a little bit warmer light. Okay, we do have a milliampere, 0.2 milliampere, and I'm going to change the temperature. It's more warm and cool. Yeah, we can see different color generation on different color temperatures as well. That's because the visible light spectrum coming from these different lamps are somewhat different, and solar lights generate electricity, or the electron depend on the energy photons coming from different spectrums. It's mainly, if we are going to discuss about the mechanism, it's mainly depend on the solar materials which used to fabricate this solar panel. Unfortunately, we don't know which type of materials used for this solar panel. Commonly it's silicon. Okay, now let's try to take this into outside under direct sunlight and see how much current we can generate from this solar panel. Then we can compare that current range with this artificial light range. Let's test this one as well. Alright, here we have the light, external light source. This one, the wires are coming from here. We do have solar panel wires here and battery. This is a common battery we can see in most of the solar lights. However, you can see no brands, specified branding here, so that means they are cheap ones too. I'm going to remove the battery. Okay, now we can see direct input from the solar panels. For this one, yeah, these will be our points, or we can use this point as well. I'm going to use this one. I will move this inside of the room, otherwise the window light will be affected. Okay. The current generation is more similar to the previous one, right? It's around micro ampere range, actually in milliampere range, 0.07. Okay. Flashlight, LED flashlight is on. All right. We seems to have a 0.1 current generation, milliampere 0.1. Yeah, 0.2, 0.25 milliampere. Interesting, even though this solar panel seems bigger in size compared with the previous one, the current generation does not seems to be large. And let's turn on this one. Right, I have to move the lights here. Since light is closer, closer to the solar panel, the current generation is high. However, when I increase the distance, the current generation is lower. It seems the solar panel inside this outdoor motion activated solar light does not create much current like the one that I have shown earlier. Changing the color tones. Yeah, we can see there is a small different, 4 different color tones, but not much, right? Okay. So current ranging in 0.8, 0.7 milliamperes. Okay, I have turned off. Right. All right, now we are in the outdoor. My 2 solar panels, DSMB's solar system solar lights, now they are in outdoor under direct sunlight. Let's check how much current they will generate with this direct sunlight. Yeah, it seems it's really high, right? It's around 38 milliamperes. So difference is really big, right? Even though inside with that small level of light source, external light source, we could generate a very small amount of light. So that means nearly to 1 milliampere, right? But right now under direct sunlight, it's ranging around 39 milliampere or 40 milliampere. So that means that's huge, right? It's kind of a 40x times the energy that can be generated inside the home. So if you are charging these solar lights through artificial sunlight, it's possible, but the thing is it will take long time to charge. So we have to keep our indoor solar lights, right, within very near the artificial light source, or we have to charge our lights under a very long time period in order to fully charge. But with the direct sunlight, the charging time will be reduced and it will be easy to charge actually. Okay, let's check this one as well. First I will move this one to the surface of the solar panel to direct sunlight and trying to keep my electrode in the proper locations. Okay, now we can see this solar panel generating more current compared with the previous one, the garden solar panel. This one is generating around 64 to 65 solar milliampere, right? Okay. Yeah, very similar to the previous one, the similar case, 60 to 64 milliampere. So that means it's possible, however, you need high power external lights, or the external light need to be closer to your solar lights in order to charge them properly, right? Okay, I think this will resolve any conclusion or any problems you are having with these solar lights, whether they can charge with the flashlight or into external light sources. And I will mount them again to work them. I think that's all for today.